Okay, so we're going to talk about gas laws today, focusing on the relationships between pressure, volume, and temperature. So, we're going to start off by talking about Sir Robert Boyle, who was one of the first scientists to actually use experimentation. He lived from 1627 to 1691, and he was an atomist. He went against Aristotle's theory that there were only four elements. He actually defined what an element was. And in 1662, he found that as the pressure on a gas increases, the volume of the gas decreases. So imagine, if you will, putting gas into a piston. If you push down on that piston, the gas molecules will squeeze tighter together and the volume of the gas will decrease. Now, this will happen as long as you hold it at a constant temperature. And you can see here from this graph that as you increase the pressure, the volume of the gas goes down. This is an inverse relationship where one goes up and one goes down, and this inverse relationship is known as Boyle's law. And the equation for this Boyle's law is P1 times V1 equals P2 times V2. So moving on, about 100 years later, Jacques Charles comes along. And Jacques Charles, who lived from 1746 to 1823, was a French scientist, inventor, mathematician, and most importantly for this law, a balloonist. And he found that as the temperature of gas increases, the volume of the gas increases. He did this because he was experimenting with the concept of hot air balloons. And he found that as he heated up the air inside the balloon inflated. So this led him to come to the conclusion that as you increase the temperature of a gas, the volume of the gas will increase as long as you hold it at a constant pressure. Now, the fact that he was a mathematician, he was able to work out a relationship, and it's a direct relationship. As one goes up, the other goes up. As temperature goes up, the volume goes up. This is known as Charles' law. And Charles' law is V1 divided by T1 equals V2 divided by T2. The one caveat to this is that temperature has to be in Kelvin, because we don't want to have negative temperature values, because that would lead to negative volumes. So a little bit later, Joseph Louis Gay Loussac, who lived from 1778 to 1850, found that the temperature of a gas, that as the temperature of a gas increases, the pressure of that gas increases. So imagine, if you will, you take a gas, you put it into a canister, and then you heat up that gas. Well, the gas molecules are going to move faster and faster. They're going to hit the container walls harder and harder, and it's going to take more pressure to hold that volume constant. So as the temperature increases, they're going to push harder against the container walls. So as temperature increases, pressure increases, as long as you hold it at a constant volume. Now this, again, is a direct relationship, and this direct relationship is known as Lusac's law. And the equation for this is P1 divided by T1 equals P2 divided by T2. As long as we measure the temperature in Kelvin. Again, we don't want to have negative temperature values because that would lead to negative pressure values. So we could take all three of these laws, and we can, the Boyle's law, Charles' law, and Lusac's law, and we can combine them together into the combined gas law. And the combined gas law is P1 times V1 over T1 equals P2 times V2 over T2. And if you look at this law closely, you could see that it contains the three variables, or three expressions that we were previously talking about. Boyle's law, P1 times V1 equals P2 times V2. Okay, so I'm highlighting that in green so that you can see how Boyle's law is in this law. You have Charles' law. Charles' law, which is V1 divided by T1 equals V2 divided by T2. So I've highlighted that in red so you can see how Charles' law fits into this expression. And then we have Lusac's law, and Lusac's law, which was P1 divided by T1 equals P2 divided by T2. I've highlighted that in blue now, so you can see how that fits into this law. Now, this law, just like the other laws, has to have the temperature in Kelvin in order for this law to work. Okay, so you have to have temperature in Kelvin. But when you take a look at it, these are the relationships between pressure, volume, and temperature in the gas laws.